topic of my very short presentation today will be making sense of serverless operations on AWS. And yeah, this is kind of to give you the preview of the talk that will be much longer in the Serverless Architecture Conference in Berlin in October, which you are all invited. And yes, my name is Vadim. Serverless is one of my passions. Probably you know me, you can contact me via different channels. Yeah, it's not the basic talk about serverless, why serverless, and the basic concepts. You need to understand the function as a service, certain AWS services, at least to have broad understanding of them. It's more about what are the operational concerns. And the thing is, this is the Werner Vogels, the CTO of AWS, speaking at reInvent probably 6 years ago. And what he said was all the code you ever write is the business logic for the future. It was, of course, pre-LLM times. And now everybody is asking, should we write the code or we should communicate through the natural language? So we have kind of different discussion, but this was more or less the answer why people should look into the serverless, with the promise that they should only focus on the business logic side. And this talk more or less explores, is that true or not, or there are also other things that we need to pay attention, and I will leave LLMs outside where they might help us in the future, maybe just to design those systems to keep the things in mind that we will be talking about. The first thing we will be looking at so-called AWS Serverless constraints, because these are operational things, and also technical concepts in mind, basically distributed systems, because serverless systems are distributed, highly distributed. I will only show certain things that we learned, especially at our company, doing a lot of serverless, like basically what to keep attention to in terms of general architectural decisions, and very short also about serverless observability and challenges there. So let's start with the first one, architect with the AWS Serverless quotas and technical concepts in mind. So let's start with a very simple application, and we will adjust it. We have here API gateway with the products API. So the whole solution basically creates the products in the database and then retrieves the product by ID. You can update the product, you can add, get all products. It just doesn't matter. It's a very simplified version. You see two Lambda functions for creating and updating the product, where the business logic is written, and I store this in the DynamoDB NoSQL database. Yeah, there are other databases. We'll very briefly look into them, but basically this is how the standard completely serverless application look like, where you don't manage the infrastructure, because all these API gateway, Lambda, and DynamoDB are managed services. So first of all, yeah, it just simply looks, we can deploy and it could scale forever, but of course it's not like this. Resources in the cloud are also constrained, and AWS has its dedicated service called service quotas, and the quotas is like constraint. Yeah, it's not only for the serverless services, but for all services. You simply search for service quota, and then you can see the dashboard. You can then do your own dashboard, only adding the services that you are using, just that all others don't confuse you. But of course, you also search for the services. You see here on the left side, AWS services, you can go and search for something. Like let's search for AWS Lambda. And this page, after you have, it just loads, you see all these quotas or constraints of the AWS Lambda. There are so many of them, but what's most important is you see the quota name, like concurrency execution. You see the default value. You see the value that you increased, yeah, what you actually use, but you can only increase. And then the last column, this red one, just adjustability is a very important one. If you see here not adjustable, that means you need to pay attention to this quote and know it, at least many of them, probably not every, but there are some important we will look into, just that you need to architect around this quota. Yeah, because otherwise you will be throttled. If the quota is adjustable, you see here account level, like on concurrent execution, you can increase these quotas by providing the use case to AWS, and they increase even automatically. But if you need somehow very high numbers, then you need to explain your use case, because they can see the numbers that you are currently using and ask, why do you need the 10x of that? Do you have 10 customers more starting from tomorrow, or 10x customers, or what's the use case? Christmas season, whatever, newsletter. So you need to do that. So these quotas are on account and region based. So each account in each region, they can have slightly different values, and that's why it's regionally dependent quota. So you can select one quota, like concurrent executions for Lambda. What you see here, you can see the values, once again, and you can see for many quotas, the monitoring on the kind of CloudWatch, that you see what you really spent, which might help you with the decision maybe to increase that. In case you would like to increase, then there is a button left in the left right upper corner. You can do this from support page as well, but I always like to do that on this page, because I have here quota request history. And I can see all the quotas that I wanted to increase or to be increased by AWS. And I see all these cases, and I see the requested values, and when it started, that it was approved or not approved. This is, I think, one of my company's account, or even my private one. So you see that you can go higher at certain quotas and increase them. So this is basically one of the starting points. Sometimes you need to dig into documentation, because these quotas are displayed in this source are very linear. You have the quota name and the value. Some quotas depend on other quotas, and it's very difficult to put in this kind of structure. So you need to contact also the documentation, and in order just to understand how this plays together. But let's start with that kind of communication. And first of all, I will only show you certain quotas that are important for API gateway in Lambda, and leave certain things for the kind of the extended version of the stock. So what's important, this API gateway, managed API? First of all, you need to understand the concept of API token bucket algorithm. And this kind of algorithm is very used in the distributed area. Once again, serverless services are microservices, and they're inherently distributed. So you need to understand what is the token bucket. So how many tokens are in the bucket by default, how they are emptied, and how they can refill. So you see here the throttle rate determines how many requests are allowed per second. We will look into these values, but there is the burst concept, and you will see this the similar. It's another concept, but there is burst concept for Lambda and for DynamoDB as well. And the bursting determines how many additional requests you are allowed per second. So you can burst for the second if you have enough additional tokens. And this throttling, there are additional settings. There are global settings. You can set it's for the values are for the all APIs in your account and region, but you can shrink them. If you say, I have deployed 10 APIs in my account, whatever reason, sometimes you have 10 accounts and each account has only one API. Sometimes you bring related APIs together. You can also set these quotas, divide this total thing between different APIs, and you can even divide it between different HTTP methods or stages. There can be production, test stage, and all. If you do it in all accounts, you can split it for the reason if you have kind of DDoS attack on the one API gateway, that it don't throttle all other APIs. It's up to you to do the math. If you see that, you have one very small service which only uses, has several requests per day, you can limit that just to not to allow some kind of attacks. Now let's see what are those values. So this default throughput or throttle rate, this is the maximum number of requests per second in your API. This is by default 10,000 for all APIs of one account in one region. And it's adjustable. That's very important. I adjusted it to 50,000. It's not a problem. You can go to the millions if you can explain. But there is another quota, this throttle burst rate, then the maximum number of additional requests per second. It's only 5,000. So you can only burst very shortly. You can increase the first value, but not the second. So this is something to pay attention to. If that default value is not enough, the burst limit, it's really very short one, depending on the first value. So there are other important quotas or constraints. Maximum timeout of the API gateway. It's the public-facing service, so nobody should wait along. So the maximum value is 29 seconds, but you can put the lower value. And now you can increase that since 1 year, because sometimes you talk to the third-party LLMs and then the answer takes time. Yeah, for that reason, you can increase that value. And there is another important quota to know about API payload size, which is only megabytes. But of course, I think it's quite a big payload because you don't need to transfer images through API gateway. You can put them direct to S3 and send the signed, pre-signed URL via payload of API gateway. So it's generally not, I don't think it's a normal use case that you have such a big, or you need such a big payload size, but pay attention to it's not for transferring a big stuff, big things. So another service, and we'll only look now into the Lambda function, you need to understand Lambda concurrency. We already saw that this is basically the most central constraint or quota. In concurrency, Lambda is the number of in-flight requests your Lambda function is handling at the same time. So how many Lambdas are executed at each time? And you see here different Lambda functions, so they can be short-lived, long-lived, and in every point in time, you have only a certain number of this concurrency. So why it's important? Because the concurrency execution limit is by default, it starts always with 1,000 per account in the region. And you can increase that, for example, to 7,000. If you say I have so many Lambda functions and 1,000 is just not enough, I have more invocation in parallel of all those functions, that's fine, you can increase it. There is a second, and it's very important because they two play together. Yeah, this execution and burst concurrency. The burst concurrency is basically works like this. You start by default with always 1,000, depending on the region. There are regions with 3,000, but basically in Frankfurt, where we're hosting, you always start with 10,000 execution directly of all Lambda function in parallel. And you can scale by each 10 seconds, you can get 1,000 more until you reach this concurrency execution limit. So once again, you need to increase that, yeah, because if you have 1,000, you always, and you start with 1,000, there is no burst. But in case you increase it to 7,000, then it will take 70 seconds to reach from 1,000 to 7,000. So each 10 seconds, 1,000. It's very important that you pay attention to this. Once again, in US West, you can start with 3,000 even. Yeah, but there are regions where you start with 500. So it's important to understand, and you cannot change this burst concurrency limit. So you need to increase that. So the question is, and we will be answering what will happen if you need more than like 1,000 or 3,000 requests in parallel right away. So once again, this is how it works. We increase the concurrency number to 7,000, and you see we start with below with 1,000. And so each 10 seconds, we get 1,000 more, and this is what our system also needs. And you see at 9:30, we have the need just to scale to 1,500 per 10 seconds, and it's not possible. You see the red 500, they will be throttled. 500 requests will be throttled, and the same will happen if we will reach the cap of concurrency limit of 7,000, and we need more. Yeah, then our system cannot handle this, yeah, with that setting, and we will also get the throttling. So it's important to understand how much is the concurrency of your account. Yeah, you also can limit the concurrency on the function level. Sometimes it's by default, it can scale to this concurrency limit. And so one function can eat all this concurrency limit of your account. And the same is we can say, okay, this function doesn't need like 7,000, it's maximal 800. And you can simply set and say, don't scale more. Yeah, if you know this, so that you don't throttle all others. So once again, there are also Lambda best practices, just because the short-living Lambda functions are better, because then the concurrency can be increased. Yeah, if the Lambda invocation takes longer, then you eat up the concurrency. So there are things to know about, to reuse the connections, keep alive, to only put the dependency that you use, so that the package size is smaller, then you have lower call start times, and then the execution of the Lambda function takes less time. So there are certain best practices. But basically, you need to also understand the quota of one of Lambda functions timeout after 15 minutes. and the payload 6 megabytes. So for API gateway it was 10 megabytes, but also the same thing here. The payload is not for transferring large objects like videos or images. Put it on S3. Okay, this was something I will leave to the conference. So once again, then the question is, if I need more than 1,000 execution of Lambda function right away, or for all Lambda functions together, if I just need more, then I will be throttled. How I can deal with that? So there are limitations. If you just simply do the stuff API gateway Lambda DynamoDB, then there are limitations. And this is, you see on the right side, this is why SQS queues are so popular. Yeah, to put SQS queue in between, yeah, between API gateway and Lambda. So why is that? Because SQS and SNS, simple notification service, are basically only two services that have standard queue. There is FIFO, it's another thing, but standard queues have nearly unlimited number of transactions per second. Yeah, so you can put hundreds of thousands messages in the same time to the queue, and then you can read from the queue. But of course, then it turns your application to the asynchronous one. Yeah, you put something to the queue, and now you need to consume from that queue, and that happens asynchronously. So you will get all the beauties of asynchronous messaging processing in the distributed system, and this is operational thing. You also need to pay attention for other limits, because this polling function, which polls the queue, basically, it starts always with 5 functions at a time. But if you have more messages in the queue, it will scale automatically, adding up to 300 function executions per minute, and up to 1,250 concurrent executions. So these are all quotas, constraints, yeah? And this scaling behavior is managed by AWS. You cannot change it. So how the things are polled is up to AWS. What you can influence is, for example, to add more memory to Lambda function. With that, you will get more CPU, and maybe the function is processed quicker so that they can scale much more quicker. And you can optimize the batching behavior, because Lambda batches 10 messages by default, but you can increase this number up to 10,000 messages in one batch if you have so many messages in the queue, so that the polling function batch one, but you can only put up to 6 megabytes of messages in this single SQS queue. Yeah, these are once again constraints, quotas, up to 10,000 messages and up to 6 megabytes. Recently, until yesterday, the maximal payload of SQS queue, so one message payload size, was 256 kilobytes. They increased it yesterday literally to 1 megabyte. So if you have such a big payload, which should not be the case, but if you have 1 megabyte payload, you can only have 6 messages in the batch and not 10,000. But generally the payload is very small, but you need to calculate and pay attention that your payload doesn't increase. You don't add the information that's not important. And implement partially batch responses, like paying attention if some message in the batch cannot be processed, that you mark others as processed, because there will be retries, and then if successful messages will be processed once again, you need to think about that importancy and all that stuff, which you might think anyway. So once again, we saw these quotas. That's why SQS is so popular. Turning synchronous communication, like we started, to asynchronous one might help with the scalability, but there are also other things to think about, yeah, like polling behavior. Once again, if you do this kind of asynchronous communication, it's worth writing to DynamoDB as batch. Yeah, and DynamoDB supports batch write item operation, where you can put up to 25 items, but not more than 60 megabytes. Once again, this drives me crazy, these constraints. So once again, you can have batch of 100 items in your polling Lambda function, but you can only put 25 items in one transaction to DynamoDB. So you can split it into 4 chunks, each 25. Why is it beneficial? Because the most time to consume to talk to DynamoDB is to establish the connection to the table. Yeah, and if you do it once and then you do the batch write item, then writing 25 items in one batch will be probably as quick as writing one, because of connection stuff. Yeah, so this is one thing to pay attention. So once again, there is other patterns, retries pattern, you need to understand how the retry behavior works depending on the error. Is it throttled? Is it normal error? Or you reach the concurrency? I will leave it to you. There are lots of metrics on AWS side that might help you to see if it works for you, but once again, you need to pay attention to it. So we talked about SQS standard queue. There is FIFO queue, first in, first out. It doesn't have such a huge throughput. Yeah, it's not limited. If you need that, if you need ordering, sometimes you need ordering, like the payment should be processed before finalizing the order and not vice versa, because yeah, you can communicate that the order is done if maybe the payment information like credit card is wrong. If you have this kind of use case, you need to look into the limits. This is much more complex stuff, how to deal with the throughput of FIFO queue. There are message groups and all that stuff, very, very complex logic also there that you need to understand. So you need to set meaningful timeouts for API and Lambda. You need to think about retries, yeah, just as operational aspect with exponential, backoff, and jitter. There's all these concepts that sometimes even AWS SDK supports out of the box. You need to think about idempotency. Yeah, sometimes you just need to think what happens if the same order will be paid twice. Yeah, or the message in SQS queue can be received multiple times, the same message that happens. There is at least one guarantee, and in very rare situation, you can receive two messages in parallel. You need to defend against that, but you have the power tools exactly for this purpose, where you can implement idempotency easier. So yeah, we only touched basically API gateway, Lambda, and I left DynamoDB and other databases like Aurora Serverless for the talk. But of course, others, CloudFront, Event Bridge, SNS, Kinesis, Step Function, even S3, they all have their constraints, these service quotas, and you need to understand them. That's why it requires knowledge, it requires understanding of the concepts of the distributed system. So once again, you need to understand them, like token bucket, asynchronous communication, retries, how the things work. But you also need to understand the individual specific terms for the services, like concurrency, transaction per second. They look a bit different depending on AWS service, especially how throttle and concurrency limit work. Burst limit, yeah, they sometimes work completely different depending on the service and how they play together. And this is, by the way, one of the things and learnings that you, that it doesn't. So you not only focus on the business logic, but on this on this operational aspects. You need to understand. Yeah, I also think like if you use DynamoDB, NoSQL database needs to be understood. But of course, you need to know and observe the service quota. They change. AWS increases those limits, like SQS payload size. It was just became four times bigger yesterday, and with that, it might allow you to do new use cases. Yeah, so just watch out for them. And once again, these quotas are valid per account, per region. So use different accounts for development and testing. That they don't consume the same limits. Use different AWS accounts for independent microservices. Yeah, separate accounts on the team level, basically. Yeah, if each team has ownership for the different services that they can communicate via HTTP, being hosted in different accounts. And of course, use AWS organizations for all that stuff that you can watch for these limits, yeah, and understand how they play together. Of course, we only talked about limits, about concurrency, very important, but there is also latency. You need to understand the latency characteristic, especially if you are in the latency sensitive application, if you go to and use asynchronous communication, because using SQS, SNS, Event Bridge, they have, sometimes you even combine those services, they have different latencies. Yeah, it's also one of the examples, like the AWS Event Bridge improve the latency up to, it's always advertisement, up to 94%, not for each use cases, it will be like that, but it's significant improvement. So only briefly to touch upon general architectural decisions. You will in some point in time, you will transform to some asynchronous communication. You need to understand the differences between SQS, SNS, Kinesis, and Event Bridge. These are basically four services widely used in the asynchronous communication, and especially SNS and event bridge. They are similar. They are push based. They have support for similar stuff, like you can connect to both several Lambda functions as the consumer, as the target, but they have differences, like SQS supports SMS type of stuff, Event Bridge supports better archiving and more targets. Yeah, SQS is completely different. It's a poll-based. You need to understand sometimes also pricing model in case you can use both of them or several of them, and they are scaled to your needs. Then look also into the pricing, because pricing characteristics are completely different. For example, SNS might be cheaper as Event Bridge. For example, if you only use Lambda as a consumer, then SNS might be a better choice. And it's also look into the latency part of them, as we mentioned. So the services are developed at AWS by different teams. So this what you see the characteristic. It's for the last year. So sometimes the features will be added, and then kind of the preference what to use might be changed. Also, the second important thing, the database choice. Yeah. I showed you DynamoDB, but of course you can use simple relational database storage with Postgres and LDS. You can use Aurora, it might scale the storage independently. You can use Aurora Serverless, that it will scale out of the box for you, as you don't need to just put some numbers how to scale. At least, yeah, you just rely on AWS doing that. And since recently we have another part, for relational database, Aurora DSQL, which even is more serverless in the terms, like you don't manage any infrastructure. It scales out of the box, and it doesn't have even cold start times, but it only supports, for example, Postgres. Yeah, Aurora Serverless can support also MySQL. So there are also things to consider. Aurora DSQL supports Postgres, but not all features. There are currently no indexes. Indexes, yes, but there are no sequences, there are no foreign keys. JSON time is not supported, PG vector is not supported. So if it's your use case and you use something like this, then probably the SQL is currently not for you. But if it's just simple CRUD operations, select, create, update, and delete, then Aurora DSQL might also be the choice for you. Yeah, maybe the last thing, observability becomes really challenging. You need it. Yeah, you need logging, monitoring, tracing. You need proper alerting, and AWS doesn't provide you such a service. So alerting, yes, but you need the incident management solution. Maybe PagerDuty, OpsGenius, or others, like you will receive the call if something went wrong. That's very important, because otherwise you don't see what's happening. So our services, we have like 200 Lambda functions. Without proper observability, it becomes challenging. And then you will be dealing with tool selection, because they're quite pricey. If you know them, Datadogs, Lumigos, yeah, observability in the microservices is not cheap. You might end doing some sampling, yeah, to decrease the cost, with the risk that you cannot identify the traces with the failures. But this is the nature of the observability in the microservices world, and especially in the serverless. You need that. You cannot just say everything is correct, the things failing, they are retrying. You need to have the stuff. CloudWatch provides you a lot of metrics, but you need also alerting. So once again, just to summarize, is that serverless that we only focus on business logic? I would probably say no. Yeah, in the classical data center, you focus on the infrastructural side, and it's very heavy system administrators world. And you might think, okay, yeah, in the AWS, taking the infrastructure part away, now I can focus on the business logic. I would say no, you need strong foundation as a developer in the designing of distributed system under consideration of those constraints. Quotas, but also you need to think about pricing, latency, and all that stuff. So it's not that easy. The thing is, of course, you can cover everything only with developers. And to put them in one team, which has the ownership of one service, they can do the whole cycle of software developing, starting from design of the system or requirements engineering, and ending up doing on-call duty. Everything, developing, deployment operations can be handled with one team. And if the team is very well trained, I personally saw that developers like those aspects. Yeah, it's just overwhelming in the beginning, but if you are doing this since time, you have time to learning, they understand and do this. Yeah, and they can cover the whole life cycle, which is a factor of speed. So if the speed matters, it's still very valuable.